All right, so this next section we're going to work through is going to be, we're still using Python here, but we're going to be using Python to do some more data analysis. So rather than just using Python to learn programming, we're going to be using this to inspect information, to manipulate data, and not in like a nefarious way, but like cleaning it, things like that. So we're going to do a lot of different stuff with this, and the goal is to learn to use these tools to interact with data in a meaningful way, right? That is our whole goal here. And that way, when you're interacting with it in a meaningful way, you're learning more about the data itself. But that means that you're going to have to know your tools. And so this is going to be a toolbox specifically set up for data analysis. Really cool. Numpy is a library, which is a little bit different than what we've used before, but we'll see how this works exactly. It's a library for the Python programming language. It adds support for large multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. A couple different vocab words to think about and things to look for. We're going to look at the shape of things, right? How many rows and columns it has. A matrix is an entire array. It's kind of like a list. Vector are variables to be applied. It's the same as the one used in physics. We'll see what that looks like. And an array is, again, similar to lists. A matrix is an array of arrays. It's a list of lists, basically, is kind of the idea. So let's just take a second and have a look here. Lists are flexible dynamic Python objects that do their job quite well, but they do have some quirks because they have specific focuses for what it is that we're going to be doing. They do not support some mathematical operations in a way that maybe we would think of when we approach them for the first time. So consider the summation of two lists, L1 and L2, right? So we're going to print, we're doing f string, we're going to say add regular Python lists together, right? And we're going to put in here L1, and we're going to add that to L2. Don't mind my laundry, the white noise in the background. Hopefully you didn't hear it. Maybe I'm just drawing attention to things, and you're going, wait, what was that? Now I'm being distracting. Anyways, and then we're going to do something else just for fun. We're going to say find the difference between these two lists. L1 plus L2. That's not now. I need to finish that there. And there we go. All right. So we should get an error here. Oh, wait. This is not a addition. This is, there we go. The difference. Cool. So the first one, we would have expected, what, 1 plus 4, 2 plus 5, 3 plus 6. You add them together, right? But that's not what we got. We just appended the values, really, right, rather than mathematically adding. And the subtraction doesn't even work. It says unsupported operand types for subtracting list and list. So it says you can't subtract a list from a list. That won't work, right? So we say, what if we wanted to sum the elements, sum the lists element-wise? And so instead, we can write our own function that does the job entirely within the framework of Python. And so your first assignment here is going to be write a function that sums the indexes of the two lists. So you can just pause the video and do that. It's just a little bit of flexing those Python muscles. But go ahead and do that. So pause the video. Go ahead. Cool, whatever. Hopefully you paused it and actually did the work. Because you won't be as good at this if you didn't. But anyways, importing. We haven't seen this a whole lot. We've messed around with it with our modules in the last Python section. But these other libraries and packages we can install and download. So this one says requirement already satisfied. It's already on my computer. But this is, fun fact, this is actually a bash script. So this is actually in the same way you type things in your terminal. When you type things in one of these, right? You can do that in Python, and it will actually run this automatically if you put it at the top of your text and use that exclamation mark. But anyways, so that's going to install it to your computer, and then we're going to import it. So obviously when I do this, it has to think about it for a second, but it says requirement already satisfied at this location. Again, you can see that this came with Anaconda. Anaconda comes with a lot of really good data tools, which is why we use it. But so that already exists, and now we can import that as NP. And now we can use that NP to pull some stuff. So let's try this. We're going to do R1 equals np.array, which is, again, a function. You'll also notice, you may remember this, when we were using our own custom modules, we would have our module name that we had made and then dot function or dot class from that function. I don't think we did classes in there, but we would use that in there. And lo and behold, it would end up actually pulling that out and applying it. Like this little yellow thing's kind of distracting to me. But in the same way, we pulled this package, np, and dot array is a function inside of np. Anyways, what we're going to do is we're going to take this and we're going to say 1, 2, 3. And then we can do R1. And this is a little bit different than what we've done before for how it actually spits it back out again. But it's very similar to R as well. R. And, oh, look at that. I meant the letter R for the language. R. I guess it's probably backwards for you. R. Anyways. Yeah, so that'll be how that ends up working. And so you can see that that's our array there, and those are the things that we put in. And that's fine, but this means that we're going to be able to utilize it a little bit differently. We're going to print type R1 and run that, and it turns out that it is not just a regular list. It looks like a regular list, close to it, but instead it's class numpy dot nd array. It's a little bit different, and we'll see more of how to use that in a bit. Let's check this out. We have np.zeros. And np.zeros has a shape that we have to actually give it. So we can say r0s equals np.zeros, and then we're going to pass in 3, 3. And we do r0s here. Look at that. We got a matrix, right? So this is actually what's called a 2-dimensional array, right? Oh no, this is a 3-dimensional array, my bad. Because we have, it has both height and width to it. So a 2-dimensional array would be just one of these, and then a 1-dimensional array would just be one item in an array, which isn't super useful. But yeah, so we got a 2-dimensional array here. That's very cool. A 3 by 3. Again, we could change this here to like 2. See what that does. And so, anyways, so you can experiment with those numbers if you want to look at that more. But that's how that'll look. Very nice. np.ones, and also so there's kind of two of these functions that are like this. We got zeros and ones. There's not like a np.twos or np.threes. And some of the value of this is that, again, you can assign an entire set of data to be either 0 or 1, like either false or true. And that's a nifty thing that you can do. Cool. Kind of like we had booleans earlier in our Python coding. All right, np.ones. So we're going to say our range. Oh, no, ones. Whoops, wrong line. Our ones. This is very similar. It's going to be np.ones. We do it again, 3 and 3. That was not what I wanted either. And then we can say our ones. Let's see what that looks like. There we go. So we got a bunch of ones. Kind of weird that they're all floats automatically. So what we could do instead is change this. Say int equals np.ones 3-3. Oops. 3, 3. And then we're going to say int at the end. And then we'll be able to do our ones int. And there you go. And now they're all integer data types, which is useful if maybe you did not want to have the float data types. All right, cool. So we're going to make things into a range. So I have our range equals np.arange. And we're going to say 1 to 12. And what does that look like, Brandon? It looks like this, which is pretty cool. So you automatically have an array, a numpy array, and we can go from 1 to 11. Obviously, keep in mind that that is not inclusive of the 12. And it also starts at 1 there. And so, yeah, pretty cool. This means you can just create a list of numbers instantaneously. Very, very useful, especially for creating dummy data or preparing things for data to go into, things like that. All right, so making lists into ND arrays. So I can say list 1. This is pretty straightforward. So we'll just have 5, 6, 7. And then we'll come over here. Our list equals np.array list 1. Pass it in. Same way that we did earlier up here. Just instead of using like hard coding that in, we can use a variable as well to do that. All right. We'll do some calculations. And then we'll see what time we're at when we get to multidimensional arrays. All right, cool. Summation. So when you have these arrays, you can actually do mathematical functions on them. That's part of why we keep using these array data types, is that they get handled a little bit differently. They look like a list, but they're going to act a little different. So summations. We're going to have our list 1. It's going to be np.array, and we're just going to do 5, 10, 15, 20, and 25. What are we doing here? Oh, I need 2 of these. There we go. That's nice. And we're going to do another one, our list 2. It was np.array, and we'll have here, we're going to do 10, 20, 30, 40, and 50. Great. So we can do result sum, and this is going to be our list 1 plus our list 2. And what we should see here is, sure enough, it actually adds them together, right? So we get some very different values here than we would have if we had done this with our regular Python list like we did at the top, right? And what's cool is not only does this add these mathematically, but we do also end up with some differences. So we can do result diff equals our list 2 minus our list, if I spell it right, 1. Right? And sure enough, we end up with the mathematical values of each one of these applied here. You can multiply them as well. Result mul equals our list 1 times our list 2. Oh, there needs to be underscore. There we go. Those got big quick. And we can do division as well. Result div equals our list 2 divided by our list 1. And this is pretty straightforward. I mean, I'm sure you can kind of figure out what's about to happen for most of these. Result div. Right, and these are each half. All the list 1 values are half of what they are in list 2. And so, yeah. Do note that these are defaulting to floats as well. So that's cool. We can also do modulo. I'm going to copy paste this because it's probably getting a little bit dry, and I think you can figure out what's going on. Great. Modulo. There's no remainders on any of these because they all go evenly. If I were to change, well, no, I'm not going to do that. And then floor division, same deal. So we've got result floor. Here, let's see what's left. And we get 2 left out of all of them. Nice. Let's see, NumPy subsetting. All right, cool. Let's do, we got all kinds of stuff going on here. All right, cool. Figured out what was going on. It was just a lot to read. All right, so what we're going to do here is, let's actually take, let me get rid of result 3 here as well. And these. So what's really going on is we can take a subset of a array here based on a true or false condition. So let's take first, let's do print result mul, right? So this is from up here. There we go, result mul. We got some pretty big numbers here, right? So what we can do is we're going to say result mul where it's less than or equal to 800, right? And print that out. And you'll notice here, we get true, 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 false, because they're all less than or equal to 800 until we get to the last value, and then that one ends up being false. It's not actually less than or equal to 800, which is a really nifty thing that you're able to do. And you might say, okay, that's really great, but that's not super helpful. Is there a better way that I can type this out? And the answer is yes. We can do result mul, and then we're going to index, like we're gonna use this to find those values back. I'm going to say result. It's very similar to using a dictionary. Result mul less than or equal to 800. And sure enough, this will actually bring us back the values where it's true, right? And so it's going to actually index with itself. And yeah, pretty cool. And then last here we have a test. I don't know why we used ND strings, but yeah, so we get that. We got this array here, and we've got Bob, Mark, Angelica, and Barb. And then we're going to print where test ND strings equals Bob, if that's true, basically, and it will pull that back. We can also probably do this. True, false, false, false. We can also say, what if I want to see just the first letter starts with the letter B, and that didn't quite work the way I wanted it to. But we go back to the original. There you go. So kind of neat. And yeah, it's a conditional check that returns the elements that meet the given conditions. That's how the subsetting works. Multidimensional arrays. Numpy seamlessly supports multidimensional arrays and matrices of arbitrary dimension without nesting ND arrays. ND arrays themselves are flexible and extensible and may be defined with such dimensions with a rich API of common functions. The API is like a collection of functions that you can access. It's just the way that data talks to each other. Of common functions to facilitate their use. Let's start by building a two-dimensional 3x3 matrix by conversion from a nested group of core Python lists, right? So we've been using our regular Python lists. That's all cool, just like this. And first, we're going to change them into a matrix. So we're going to say M equals A list, B list, C list, right? And so now we can just spit M back out. And sure enough, now we've got these nested lists. That's great. And now we're going to put it inside an NP array. So we're going to say ND M equals NP.array. And we're going to pass in M. We're going to print oops, there we go. And see what that looks like. And we get that back. And if we were to also try and return NDM, we can see it looks like this. And it's an array data type. And so that's going to be something we'll be able to use later. If I got rid of this part here, you can see that's nice and organized. It's just a little bit harder to read with the thing. Actually, let's do this. Let's do... There we go. That's easy to read. Nice. Delightful. All right. Indexing ND arrays. How we get this? This is, again, very similar to lists within lists. The syntax looks more like C programming language. Brandon, why? Because Python is written with C. The rules for how Python handles our data are written in C. It compiles down to C. We've talked about this a little bit. And so it ends up being a little bit backwards. So 1, 2 is going to be the second row, third element. And so that's not backwards. We'll see what this looks like. Here we go. So we say print f string, and we're going to say getting the middle element within the matrix. And we're going to pass in NDM. I'm going to look at 1, 1. And again, the reason that we do this is this is actually pretty much the same as Python. Now that I'm thinking about it, I know C as well, but it's pretty much the same as Python. Just keep in mind, like again, it's a 0th row, 0th row, and 0th column, as well as a first row, first column will be right there. I'll spell getting right too. That'll look better. There we go. Cool. So that pulled back 4. That's very nice. So again, second row, third element. So this is going to be 1, 1 here. And so if I wanted to get back 5, I would say, again, the 1th row and then the third element. So then we would have 2 here. And sure enough, we get back 5. So that's how we would be able to do that. And that's nice. Assigning values in ND arrays. We can also just overwrite things. So if I wanted to change that number to 9, I could do ND M. And then we're going to say at 1, 1. I'm going to say that equals 9. ND M. And that works out just fine. The reason this is in here is because I believe we used to teach some of this stuff to people who did not take our Python content. And they didn't want to learn Python. They were just going to learn this stuff by itself. And so we have some things in there that are more programmer oriented, but I've already primed you guys for that pretty well, so you should be fine. Notice how we ended up with a 1 in the target element's place as a data type issue. I don't see anything weird. Remarkable. All right, cool. Yeah, that looks fine to me. I don't know what they were expecting there. Joel, what are you doing? All right, cool. So using the ND array type, we say ND type equals ND slash or underscore M dot D type. And we'll see what this looks like. I would think we need the parentheses, but my notes don't say it. Not sure enough that it works. What happens if I add these like normal? Oh, okay, nope. It's just an attribute. Cool beans. So we can see it's int64. This might look a little bit different for you, depending on your computer and how it actually is handling things. Don't worry about exactly what that is. It has to do with how many bits your computer uses. All right. So altering the ND array type, we'll have result t equals ND type. I'm going to say print f. Oh, yeah, you can. Okay. Type before change. Result t. We're going to see exactly how you can change the thing I just told you was based on your computer here in a moment. ndm.as type. I'm going to do np.float 32. We'll see if my computer will let me do 32. This will be interesting. This will probably not be something you do on a regular basis, but it is part of how NumPy works, so we're going to look at it. All right, cool. It did let me move it to 32-bit. And let's see what NDM, if it changed anything there. Nope. All right, so it's still float 32. It just is hiding things under the hood, and that's okay. All right. Oh, so this one, this is cool too. Using shape. Let's do. Cool. So we can just do that there, nd underscore m dot shape, and that will send back the shape of this, and so we know it's a 3x3 array, which is pretty nice. It's always rows by column. Again, we just did the same thing here, checking the shape of the array using the method dot shape, and again, we can do this here with result change as well. And again, that's just an attribute of this thing. So it's not a function that we're running on it. It's just an attribute that exists on it. So that's just fine. And let's see, what else could we do? We can change the shape. And then I'll send you off for an in-class exercise. So things we can do here, we can say print result changed, which we already have. Let's just go ahead and look at that. Great, fine. But what if I were to use the reshape function and say I want it to be 1 high by 9 long? And sure enough, there we go. We get that now. And you may also notice that, oh no, it was the same numbers. But we did change it to floats. And I wonder if we can do this. Nope, won't let me do that. That's okay. Oh, I have a different number of. Nope, won't let me do that. Okay, that's fine. It's worth a shot. I just like playing around sometimes. It's a good way to learn. You'll also notice that as I'm playing around with things, even though I've done a lot of this stuff, well, I've done all this stuff, but sometimes I just come across a different context. Obviously, teaching's a little bit different than the actual work, and so there's going to be different ways of thinking about things sometimes. And yeah, it's good to play around with stuff. If you have questions about things, please go ahead and play around with them. Break stuff on purpose, see how it breaks. Highly recommend and encourage experimentation throughout this whole process. Should be pretty cool. Keep in mind that the shape numbers do matter. 9.1 is different than 1.9. So this would be a great place to experiment with this. I know what it's going to look like, but there you go. So now you just have one column and a lot of rows. So in class exercise number 2, create a matrix of range 0 up to 16 and reshape it into a 4x4 matrix. So you should have output that looks about like this. So you go ahead and do that, and I'll see you in the next video.